Hi everyone. Today I will present my final project about the fraud prevention. And for this project, I separated it into 7 parts shown as this table of contents. Firstly is introduction, and this project mainly aims to predict and identify the fraud transaction using some known information like uh, credit card fraud transaction records, and so that customers would not charge for that they didn't purchase. And based on TensorFlow technology and the Python Jupyter Notebook, I set up one neural network to predict whether fraud or not for each transaction in Google Colab environment. And for the dataset description, you can find this dataset from Kaggle using this link. And there is 31 columns, input features called, time, amount, and V1 to V28. It's worth mentioning that feature V1 to V128 is principal components obtained by PCA, and because of some credential problems, so we couldn't get the specific variable names from that. So, and the output feature is class, one represent for the positive and fraud samples, and zero otherwise. It's worth mentioning that it's more than 200,000 transaction records in my dataset, which only less than 500 positive samples. That means fraud transactions in our dataset. So it seems a very imbalanced dataset. Then you can follow the next installation and configuration steps to install your the necessary dependencies in your working environment. However, you also can use the Google Collaboratory to run this script to get the best model and the best performance result. And then the data processing. Actually, I want to use this script to run this in real time to show how it works. Wait a second. For the first step is create some prerequisites, and we need to connect with our Google Drive. And then import some basic and visualization neural network and evaluation and resampling dependencies, and then connect with our Google Drive, which stored our credit card fraud transaction dataset. And the next step is the EDA process, is dataset processing. And for the first three part cell of the code that represent for the calculating the neural and missing values and identify each data set, each variable state type, and that can be fit in, make sure that can be fit in the neural network model. And we can see that there is all of the data set is have non-missing value and new values in the data set. And all of the B tab is for the float 2064 or int 64, so we can use that directly, and needed to get the one-hot encoding or something else technology to pre-processing our dataset. And for this side, it mentioning that the relationship between each variable with the resulting feature class. So that means maybe the time, uh, the relationship between the time and the class, and the relationship between the V1 and the class. So we can have a overview of the data size of the relationship between the result class. And it's just one step of the pre-processing. And but the calculate the correlation is very important for this process, because each variable correlation to avoid the multilinearity and make sure each variable is independent, so that we can get better performance and not exaggerate the specific variable significance during training. So we can see that no two, there is no two variable correlation higher than 0.5. So that means we won't face some correlation or linearity problem in the future. And then we also find that the data set pre-processing is imbalanced data set with I mentioned that before. It's a very significant question, and I want to use the smart technology to resample our data set and balance the target class or labels. Yeah, and the process or the steps you can follow these. And finally, after split our data set into the test and training data set, we can get the zero label and one labels very similar or equal amount. So the next step is model architecture. Architecture that includes three kinds of layers: input layer, hidden layers, and output layer. Actually, input layer, the action, and the hidden layers action activation function using ReLU, and the hidden layers number of nodes is 64 for each hidden layer, and the output layer, the action activations function is sigmoid, as usual. And we also choose the batch normalization and drop out in measured in my layers, because we can use a normalization and regularize the our data set or neural network the data set to get better performance and make that process more efficiently. Yeah, that is makes sense. Uh, and I also use the early stop function that can avoid the overfitting and the time-consuming problems in the future. So after we define these functions, matches, and other hyperparameters, we can train our model. Yeah, and it's also worth mentioning that learning rate equals 0.001 as our learning rate, because this is a can get a better performance and don't face some time consuming problem. So I think this is the best one. And I have tried some other learning rates, and this is the best one. So I choose that. So, and then training model is about, okay, we can we can wait some times because it's about the uh, 60, 60 epoch that can be early stopped. So we need to spend 1 or 2 more minutes to waiting for it process. Oh, and the loss function, I choose the binary cross and crawl in trophy. And I think mm, it's a kind of best one of the best performance loss function in this case because we want to classification of our data set. Yeah. So then 20 posts more we need to run. We need to train. We can also can see that the validation loss and the training site loss get little and little, get less and less. Yeah. So that means our model's performance is getting better. Uh, yeah, and get more accuracy, more approach we need to spend, we need to run. Okay, because of this is a black box and the neural network can be trained in different ways. So it may be have some different stop and early stopping endpoints or something else. So in this case, that would stop at the 50 epoch 57. And but we can also get the best training loss as 0.0028 and the validation loss is 0.00664 and it's also better than our 63rd approach. So it's not so difficult, but and it doesn't necessary and matter in this case. So we can also use this chart as an example or this chart as an example. We can find the best performance as the last approach. Yeah. So after that, we can get the best performance model, and then we can predict the the test set results and compare the test set actual results to get the model accuracy and evaluate our model. So the conclusion is very important because the evaluation here can be used the confusion matrix to evaluate. However, we couldn't only use the confusion matrix to evaluate our classification model because I only resampled the training side to balance data sets, data classes. However, we also need to calculate the F1 score and ROC curve to get better performance. Unfortunately, you can see that we got in this case we got the 0.6 0.76 sorry 0.676 of F1 score, and in this case we also get the 0.76 of the F1 score, and our OC curve is also very close. In this case is 0.91, and in this case is 0.93. So in a nutshell, this model can better classify our the fraud transaction and the credit card normal transaction. So from this whole project, I find that at the beginning, we need to find a balanced data set, original balanced data set that would help to get better performance. And if we can get to know the original data set and the variable names would help to us understand business question and insights. This report helped me understand more about the credit card fraud detection and help me step into financial industry and the data science area. Yeah, actually that's it. But we face some. I also learn how to face the imbalance data set and how to solve this problem from this project. That is very good. And thanks for your listening. Bye.